Another step in capacity planning is evaluating your alternatives. Suppose that you have figured out how much capacity we need, then now you want to evaluate the capacities and then find the best alternative that you have. In evaluating the alternatives possible for you, you should do this evaluation based on different perspectives. For example, the economic perspective is an obvious one. Um, you should ask, is this alternative economically feasible? Can you afford it? Can you afford it? Did the cost is the cost um, worth the try? Or how much will it cost actually? Or how soon can you get the alternative working? And other question like what will the operating and maintenance cost? So it's not just about purchasing the fixed cost of purchasing the equipment. It's also the operating the machine or the equipment. So it's going to be the operating cost and the maintenance cost. So you need to consider all of these aspects, economic aspects. Or the other part of this economic evaluation is the useful life of the alternative that you're considering. How long this is going to last on average? And will it be compatible with the other actually machinery and equipment and the facility in your system that you have? If it's not compatible, then it's useless or it won't operate in the maximum capacity that it's designed for or the practical capacity. So these are the economic considerations. There are other considerations that are not economical. For example, the non-economic consideration can be the public opinion about the alternative that you want to do. For example, the negative impact of the outsourcing, especially if you consider the politics of today's in USA. Shipping the jobs overseas is one of the hot topics in politics because people are frustrated that they are losing their jobs because of the globalization and the shipment of their jobs into overseas or the outsourcing of the manufacturing jobs. And of course, if it could be beneficial for you, it could be um, less costly to instead of operating in-house, manufacture it in-house, outsource it and ship the manufacturing out overseas, but it's going to give your organization a negative um, opinion in the public eyes. So that's another thing that might want to consider. Also, other types of non-economic concerns, such as the sustainability issue with the alternative that you pick, or the safety of it, or any other types that you can consider. So when you want to evaluate the alternative, you have to consider all aspects of um, the alternative from all the angles possible. Evaluating alternatives in economical aspects or the cost volume analysis is an example of economic consideration, economic evaluation of alternatives. That's actually easy to study. So it has a little bit of math and it's tangible to understand it. So here we want to study that, the cost volume analysis. The cost volume analysis consider the cost associated with the alternative that you have and also consider the profit of that. So what you want to do if you want to see that whether the alternative is actually profitable given a time horizon, whatever it is. In evaluating the cost, there are two types generally. There are what is called a fixed cost, um, FC, fixed cost. These are the costs that are um, they are independent of how many items you produce. So they are fixed. That's what they call they are fixed, um, and they're constant. And it's regardless of the output value. For example, if you want to increase your capacity, expand your capacity, and you um, rent or purchase a property, you already have paid for it, or you still are paying for it, no matter how many you're producing, or if you're producing zero. It doesn't matter, you have to pay for it. So this is a fixed and constant cost that's going to be a burden on your organization. Or the property tax, for example, is another example. Heating and cooling expenses, and the purchasing cost or the Um, any other type of cost that you can think of that is fixed, that is constant. These are called fixed costs. Then on the other hand, there are costs that um, are dependent on the number and the volume of your production. These are called the variable costs. So the more you produce, the more quantity you have, the more volume, the higher volume, there's going to be higher cost in production. Um, we call this by variable cost because it varies. So here is VC is the variable cost. An example of that is the material and labor costs associated with production. So the more you want to produce a product, the more the material you need, right? And also the more labor cost is gonna required. So the variable cost can be think of as a function of two parameters here. One is the quantity of the production, how many, or the volume or quantity of production, that's how many product you want to produce, multiplied by the variable cost per unit. So the variable cost per unit is the cost to produce one item, one single item. If you want to produce n number of items, then the cost would be n multiplied by v. Or here, if you want to produce q, the quantity that you want to produce, the variable cost would be q multiplied by the v, the cost per unit. And the total cost here is a function of a summation of actually both these costs, the variable cost and the fixed cost. So the total cost TC is equal to the fixed cost FC plus the variable cost VC. So that's the total cost. But on the other spectrum of cost, there is profit that you will make. And the profit that you make, of course, is going to be dependent on a function of the quantity that you produce and sell. Here, for simplicity, we assume that the Q, the how much you produce is equal to how much you actually sell. Just for simplicity, we make this assumption. So the total revenue or the total revenue TR is equal to the revenue per unit R multiplied by Q, the quantity that you sell to customers. And now we have these two. We have the cost and we have the total revenue. Using these two, we can evaluate the alternatives based on the profitability. Also, at what quantity an alternative becomes a viable option and or an economical option. There are certain assumptions in the cost value volume analysis that we went through a couple of basic examples that is important to consider. The cost volume analysis is a valuable tool for comparing capacity alternatives when you want to do capacity planning. If certain assumptions are satisfied, these are a list of assumptions for cost volume analysis that we have performed before. The first assumption is that one product is involved in the cost volume analysis. The second assumption that we mentioned it before is that Q4 production is equal to Q4 revenue. That means that we assume that whatever we produce, we will be able to sell. That is actually a big assumption. It's not necessarily true, as you might have already thought about it. So this is a big assumption. Another assumption is that the variable cost V is the same, is constant, no matter how much volume you produce. This might be also a big assumption because it's possible that if you have mass production, your per unit cost may actually decrease. So this is another assumption to consider when you do cost volume analysis. Another assumption is that the fixed costs do not change with volume changes, or they are step changes. So we already have example of this. The fixed cost is going to be constant, and no matter how the volume of production, or as we saw in the 1 and 2 and 3 machines, The fixed cost actually was it wasn't actually as simple as multiplication of the fixed cost for one machine by the number of machines that you purchase. So this is called the step changes. Another assumption is that the revenue per unit is, again, regardless of the size of the volume. So how many you sell, it doesn't matter for the price. This is, again, a big assumption, because assume that you have um, a big customer. That means that the customer that buy in bulks. So in those scenarios, usually they would expect some discount. So that means that for that customer, you're not going to get the same price or revenue per unit as you would have for a smaller customer. Another assumption is that revenue per unit exceeds variable cost. So if you look at the formula again, the in the break-even point, it would also make sense that in the denominator, so we had fixed cost divided by R minus V, and R apparently must be bigger than V, the cost, otherwise it would be a negative value. That wouldn't make sense. So this is another assumption that we have made for the cost volume analysis. Break-even point. So as we learned before, the total revenue that you make and also the total cost is a function of the quantity that you actually produce and sell to customers. So there's a concept called the break-even point. That's a quantity, the volume at which if the total revenue is equal to the total cost. That means that you are break-even. You don't make money, you don't lose money. So that's the break-even point. And that quantity, we show it by QBEP, Q break-even point. So this is the quantity, again, that at that quantity, you don't lose money, you don't gain money. The total revenue is equal to total cost. So if you produce and sell more than that, more than QBEP, you're going to make money. If you produce and sell less than that, you're going to lose money. So it is important to have this break-even point for your analysis, and also for considering and comparing multiple alternatives. So this is a very simple formula. The concept of break-even point that is that your profit, which is the total cost, you don't have any profit. That means the profit is actually zero. So profit is zero, and profit is equal to the difference between total revenue minus the total cost. That's your profit. So this is equal to zero. This means that the total revenue is equal to total cost. So R multiplied by Q minus the cost, which is FC plus V multiplied by Q, is equal to 0. And from this, you can derive this equation. Let's do it here. So we say profit is equal to 0. That's the break-even point. At what quantity profit is equal to 0? So this means that the profit is the total revenue minus total cost. So this is equal to 0. What is total revenue? Total revenue is Q multiplied by R. R is revenue per unit, Q is how much you produce and sell, minus total cost. So total cost is fixed cost plus variable cost. Variable cost is a function of Q as well, V multiplied by Q. So we make this equal to 0. And from this, you can actually find the Q. And Q would be equal to this. This chart shows the cost volume relationship when you do evaluate the alternative economically. So we learned that the cost can be broken down to the variable cost and fixed cost. The first chart that you see here on the upper left, this shows the quantity of production on the x-axis, and on the y-axis it shows the dollar value of cost. So we want to actually plot the plot for the total cost, which is going to be fixed cost and variable cost. The blue plot here, the blue line here, shows the fixed cost. As you see here, the cost is fixed no matter what the quantity. So if you go left or right on the quantity axis, the cost doesn't change. It's the same. The variable cost, however, is dependent on the quantity. So as you see here in this red plot, that shows the total variable cost. So at the very beginning, if you don't produce any product, it's going to be zero as shown here. So it's going to be zero. And if you produce more, that means you go on the right hand side of this x-axis or q-axis, the variable cost is going to increase, as you see here. If you add these two up, the variable cost and the fixed cost, so this is the fixed cost, this is the variable cost, is going to give you this total cost right here. So total cost is variable cost plus fixed cost. Also, the next actually plot here shows the total revenue. Total revenue, TR, as you remember, it's actually a function of revenue per unit multiplied by quantity, R multiplied by Q. So it's a function of Q, quantity. So as you see here, if you produce more, or if you actually sell more quantity of product, your total revenue is going to increase. That's why you see this relationship as it is here. So now we can compare the first chart and second chart to figure out the break-even point. The third chart here, it shows the break-even point. So it's actually a mix of the total cost that we had in the first chart and the total revenue from the second chart. If you actually plot both of these in one chart, it's going to give you the third chart that you see here. So this is, at this point, as you see here, the total revenue plot or line crossed over the total cost. They have a crossover. So this is going to be, that means that the quantity that total revenue is equal to total cost, means that you don't make any money. There is zero profit. This is, as we learned, is called the break-even point. So this is the break-even point. If you produce and sell more than this, you're gonna make money. That's on the right hand side of this. You're gonna make profit. If you produce and sell less than this, less than QBEP, you're gonna lose money. So as you see here, it says loss. Here is profit. So this is the break-even point quantity. If you plot the total profit, if the revenue minus the total revenue minus the total cost, or the profit actually, plot, as you see in the fourth chart right here, this is going to be the break-even point. So that's where you see zero profits. This is quantity. This is actually dollar value. So as you see, the dollar value here for BEQ is zero. So this is the break-even point. More than that, if you produce more than that, there's going to be profit. If you produce less than that, there's going to be loss. Suppose you are considering evaluating and comparing two alternatives based on the economic evaluation of those. There might be actually a quantity at which the two alternatives are equal. That means you are indifference between picking one based on the economic consideration. So in the fifth chart, as you see, we have alternative A, which is shown by this red line right here. That's profit from the alternative A. And we have the alternative B shown by this blue line here. So in the x-axis, again, we have the quantity, and on the y-axis, we have the dollar value. At this specific quantity in which these two lines cross over each other, that means the profit made through alternative A is equal to the profit made at with alternative B. This is the in what is called as indifference points, the quantity that would make two alternatives equivalent economically. So try to investigate and understand this more. There might be a question in the assignment or in quizzes or exams from this.